Okay, so today we're going to work with the unit circle. The unit circle goes in a counterclockwise direction. So if I were going to fill out degrees, this is my starting point right here. So if I were to start here, what degrees would I be at? 0. 0 degrees, if that's my starting point. If that's my starting point and I go halfway around my circle, what would this be? 180 degrees. Right? And then all the way around again? 360. If this is 180, what's this? And this? And this? What about this one? 45. Okay. Why 30? You're right. Can somebody tell me why 30? What? Okay, it's a third of 90, and yes, this thing is very symmetrical. Okay? This is 30. If this is 30, good. Okay, does everybody see how that works? And you could go all the way around that way. This would be 30 more, right? Plus 15 more, plus 15 more, which does not happen to be 30. So do you see it? Like this is 30, 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 right? And half of 30 is 15. So you could go in increments of 15, you could go in increments of 30, you can go in increments of a quarter, that's a quarter, and another quarter, and another quarter, and another. It's a pie. You can break it up in pieces, right? Okay, are we good so far? Fantastic. Why are these significant to the unit circle? What do you think? You go back. Ryan.
I feel like the theory behind how they're trying to make up the angles that make it 360.
You're almost there. You see this? 30 degrees? Check this out. I think I will wait. Give me a second. No, why not? I'll go forward on it. Okay, does everybody understand that this is not 30 degrees? This is where 30 degrees is?
Yeah.
If I were to take a protractor, your 30-degree angle is right here, right? It says if I measure from here to here, that's 30 degrees. Make sense? Okay. So what if I were to do this? That's a 30, 60, 90 triangle. 30, 60, 90 triangle. Okay, let's go back a little bit. So yesterday, do you remember what this is? Square root 2. Right? It's bigger by root 2. What about this one?
Radical 3.
Bigger by root 3. What about this one?
2n.
Uh-oh. Good. Bigger by 2. So what if my hypotenuse was 1? So instead of multiplying to get that, what would I need to do? Divide. Let's do the easier one first. How do I get from, before I had to multiply by root 2 to get here, so what should I do? Divide by root 2. Okay, well, why am I going to do this over here? Why is this not okay? See it? So this side is root 2 over 2, and this side is root 2 over 2. Let's do this one. If this is 1, what is this? What? That would be a half, because if it's bigger by 2, if I do the reverse, see how it says normally I would multiply to get the missing dimensions? So now what should I do? I should divide. So I'm not going to multiply by 2, I'm going to divide by 2, so this would be 1/2. If this is 1/2, now I can multiply, right? What would this be?
1/2 radical 2.
Or √3/2? See written like that? Okay, now let's use this. I'm actually going to take a picture of this. And drag it into the next page. We'll just leave it down here. Make it a little bit smaller. Is that okay? You get the gist of it? Okay. So, removing this, check this out. Okay, so if this is 30, do you notice that this right here is 1? Because I told you, right, it goes all the way around 1. So if that's my hypotenuse of 1, this is my hypotenuse of 1, what would this figure, and I want this coordinate right here. Coordinates are xy coordinates, right? Well, isn't this my x-axis, and isn't this my y-axis? If this is my x-axis, and I told you this is 1, what would this coordinate be? 1, 0. In order to get there from my origin, wouldn't I have to go over 1 and up 0?
Yeah.
What about this one?
1.
I don't move side to side, and I have to go up 1. What about this one? Negative 1, 0. So I'm going to use this triangle right here to figure out how far I have to go over on my run and how far I have to rise. Well, how far do I have to go over on my run according to this triangle? Radical 3/2. And how far do I have to run? 1/2. You see it? I just need to turn it, right? And then it needs to be flipped. Rotate. No. That's not going to work. Rotate it what, guys? Help me out. Oh, you know why it's not letting me? Because I already turned it. Do you know what I mean? So now, how do I want it?
That way. Down vertically.
Rotate it 90 degrees.
Yeah.
There we go. That only took 5 minutes, right? So do you see how you have to travel if I were to start here on the origin? You didn't put it here. No. That's not fair. There we go. You see that? Even though you can't really read it. It's √3/2 in this direction and up 1/2. You see it now? Okay. Clarissa, whatever you were doing, please stop. What? Yes. You need to pay attention. You have... No, you're not. Okay. So I'm going to take this one away. Got it? I'm going to take that away and that away. Let's draw another one. So if this one is, I'm going to do the 45 now. 45 degrees. If this is 45 degrees, and this is 1, what's this side? Square root 2 over 2, and what's this side? Square root 2 over 2, so what's this coordinate? Square root 2 over 2, what's this coordinate? Square root 2 over 2, right? What would this one be?
That would be 1/2 and then radical 3 over 2.
Yeah.
It's just the opposite. Yeah, 60 and 30 traded. That's the only thing that happened. Right? So if this is a 60-degree angle, and this is 1, then what would this side be? 1/2, and what would this side be? Root 3 over 2? Isn't that just these two switched? How are we doing? Okay? All right. I strongly suggest that you go home and rewatch this tonight. You got me? I'm not done yet. So this is 30 degrees. This is the one I'm going to save, so I'm just making it look nice. Which one do you guys want me to keep up here? Do you want me to keep up the 30-degree one for your reference? The 60-degree one? Why? Just because? You're just trying to be argumentative? Okay. I'm going to do 30. Actually, I kind of like your idea. Because if we do the 60-degree one, it won't be in the way of my whole thing showing that that's 30 degrees. Got it? Not a very good one, but it'll work. I actually don't like it at all. I'm doing it again. I'm sorry. It's funny that you guys just laugh at me instead of getting irritated. All right, one more time. We'll try it. This is the last time. There we go. It's a tool. Is that better? So you can see it? Are we good? Okay, moving on. All right, so here's the second piece to this. You know how your calculator has degrees? What are you doing? Okay, now we know what Clarissa was doing. Recording again. Okay, so you know how your calculator says radians and degrees? And sometimes if you come up to me and you can't do something, I say maybe it's in radians and you got to put it in degrees. Or have you ever heard that before? Yeah. Okay. So this is what a radian is. A radian is the measure halfway across this pi. We measure radians in pi. Go figure. Okay? So how many pies would I have if I tell you that this is 1 pi? I have 2 pi. So in a unit circle, there's exactly 2 pi radians. So if 1 radian is pi, what is that in degrees? 180 degrees. Right, so it's right there. Right? These two equal each other. So what's this in radians? 0. 0 pi or just 0? Okay? So you guys ready to do this? All right. If this is 1 pi, how much is this?
1/2.
Half of a pi. If this is a half of a pi, what would this be?
1/4.
A quarter of a pi. If this is a quarter of a pi, what's a little more than a quarter of a pi?
1/3. 1/3.
1/3 of a pi. Check this out. If that's 1/3, then what would this be? 2/3. What would this be? What is 3/3? 1. 4/3. 5/3. 6/3. 7/3. 8/3, 9/3. Wait, that's not working right. Okay, hold on. So if this is 1/3, I'm totally making them, I'm counting by 6, aren't I? Okay, sorry, let's try this again. Rewind. If this is 1/3, and this is 2/3, and this is 3/3, where would my 4/3 be? Not in the middle. 4/3, then 5/3, then 6/3, which is 2. When you're doing this, and I'm so glad I just modeled that, it was totally on purpose, right? Yeah, exactly. When you're doing this, that's how you check to see if you got the right answer. Because if you go all the way around, I like to say the clock, you should come all the way back full circle to 2. So let's try the fourths. If this is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Does it work?
Yes.
Okay, you see I'm doing it? I'm just breaking it up in fractional pieces. All right, so if this is 1/4 and that's 1/3, what do you think this is? 1/6. So if that's 1/6, what's this? 2/6, 3/6, 4/6, 5/6, 6/6. Is 6/6 pi? So we did that right, correct? Okay. Because if this is 1/3, isn't this half of that? Okay? You see what I mean? If that's 1/3, then half of that. If this whole thing right here is 1/3, that piece of pie is 1/3, then half of it would be 1/6. But really, all you have to do is remember this. Pi, this is 0, this is pi, and then work backwards, right? What's half of that? What's half of that? What's half of that, right? Make sense? Okay, so that's radians. Now let's finish our second quadrant. Okay, so just like I was saying, let's start with the degrees first. If this is 90 degrees, then what's this one? Remember what I said? This would be 120. Then what would this be? If that's 120 and that's 150, what's this? 135, right? Because to go from here to here is 30 degrees, so half of that's 15. So you guys can finish, right? Totally. It's jumping by 30, then 15, then 15, then 30, then 30, then 15, then 15, then 30. All right, let's do our coordinates next. We should have started with our coordinates. Okay, so what's this coordinate again? 1, 0. And what's this one? Negative 1, 0. So what do you think this one's going to be?
Oh,
And 1/2. It's the same as this one, only in the negative direction on x. Right? So what would this one be? Negative √2/2. √2, no, it's going in the positive direction. Then what would this one be down here? Let's see. If this one is this one, then that one would be this one. What would this be? Negative √2/2, negative √2/2. You getting it?
yes.
You see it? It's a graph. It's a coordinate grid in a circle. Okay? All right, let's do the radians. So we said if this is 0 and this is pi, which one do you want to do first? Let's do the halves first. So I have 1/2, 2 halves, 3 halves. Yep. 3 halves pi. 4 halves pi. What's 4 halves pi? 2 pi. Did it work? Yes. What do you want to do now? Fourths? I'm telling you should. Starting with halves, then the next one would be fourths, right? Then what would you do? Thirds, then sixths. By the time you get to the sixth, you should only have to fill in very little, right? Okay, so if this is 1/4 and this is 2/4, then what's this? 3/4. 4/4, does that match?
Yes.
5/4. Oh, I don't even have to do this one. You guys are going to do it. 5/4, 6/4, 7/4, 8/4. Does it work?
Yes.
Alrighty. Do I need anything else here? Or what am I going to next? Thirds. 1/3. What would this be? 2/3. What would this be? 3/3. Does it match? Yes. This would be 4/3. 5/3. 6/3. Does it work?
Yes.
All right. Finally, 6. So 1/6, 2/6, 3/6, 4/6. What's this?
5.
5/6. Let's double check. What would be the next one? 6/6. Does it work?
Yes.
Yes. You ready? Convert each degree measure into radians. That's what we're going to do next. I'm going to pass out your worksheet. Okay, so there's one more thing I need to show you. Converting each degree measure into radians. Okay, so remember I said that 180 equals pi? Right? So I could write, what is this? 1. So what is this? 1. Why? Because couldn't I substitute? Isn't pi 180? So couldn't I make that 180? And what is 180 over pi? 1. So if I want to convert this to radians, I would say 90 over 1 times. Which one would make me cross off the 90 degrees and give me radians? This one or this one? A or B? A. Pi over 180. Aren't I just multiplying 90 by 1? Okay. So 90 over 1 times, and you don't have to get this detailed, but I'm going to. 90 times 2 is 180. What cancels? What are you left with? Pi over 2. Wasn't 90 degrees on our unit circle pi over 2? Right? 180 was pi, so 90 must be half of that. Half of pi. Or pi divided by 2. Okay, let's do this one. How many of you remember what 60 degrees was? Pi over 3? Right? So, but we're going to like write it out. So 60, this is, if you remember that, I don't mind if you just go straight to it, but you need to at least do this. Okay? Which is pi over 3. 315. Huh. I better break that up. I know there's a 5 in there. 5 times what? 5 goes into 30 how many times? 5 goes into 15 how many times? 63. Right? Play with numbers. I wish Evan was here. Because then I could argue with him about his calculator and how he doesn't need it. We love you, Evan! So, you don't get it? I'm recording and he's going to watch it. Okay, so 180 would be 9 times 2 is 18, right? Times 10 is 2 times 5. Do you see how I did that? 18 times 10 and 2 times 5. So the 5s cancel. And there's a 9 in there, which makes it a 7. So my answer is 7 pi over 4. Pretty easy? Let's continue. Now let's go back. Convert each radian measure into degrees. Do you remember what pi over 6 is? What? 30 degrees. Good. Okay, so pi over 6. Which one am I going to use? A, pi over 180, or B, 180 over pi? 180 over pi. Why? Because they cancel. Exactly. So we can just do this pretty easily. Pi cancels, pi can't. How many 6s are in 18? 3 with a 0. 30. The answer is 30 degrees. This is easy. I'm glad you say that. So this is 30 degrees. What's pi over 3? 60 degrees, right? But let's just write it out. Pi over 3 times 180 over pi equals 60 degrees. What about 7 pi over 4? Didn't we just do that? 315. Good. Yeah, this is all you have to write out. It takes 10 seconds. And Mrs. Mahler's doing all this homework with you.
Thank you, Ms. Mahler.
You're welcome. 315 degrees. Can we move on? No. All right, so here's your unit circle. Bye-bye, unit circle. Now you take care of it. What did you learn today? Unit circles. Special triangles help us find what?
Coordinates.
Coordinates. Good job. That was quick. Special triangles help us find the coordinates. On your assignment sheet, I'll get it for you. Draw both special triangles with a hypotenuse of 1. I'm going to show you guys one more thing, really, really quick. I'm going to do it on the document camera, though. I'm going to show you what I'm going to give you tomorrow, okay? Have a good day, Evan.